Okay, 26, this is just like our last one. We have two right triangles that we're solving for the sides, and then we're going to compare if they're similar. So we're not using side ratios. We don't know they're similar. First, we have to use the Pythagorean theorem, and then we'll see if they're similar. So let's start with our first one. C is always the hypotenuse across from the right angle. A and B are the legs. It doesn't matter what side you use. So a squared, 6 squared, b is x, and then c is 10. So to get x by itself, I'm going to minus 6 squared from both sides. So I have x squared equals, and now I'm going to go to my calculator. So 10 squared minus 6 squared is 64. And then square root both sides. So x equals 8. All right, now let's look at y, which is the hypotenuse. It's across from the right angle, and a and b are the sides. So same thing. A is 7.5 squared, b is 10 squared, and c squared. And we're going to just be able to put that in the calculator because they're on the same side of the equal sign. So 156.25 is c squared. But we don't want c squared, we just want c. So we take the square root of both sides, which is 12.5. So I'm just going to erase that. That is 12.5. And that's going to help me look at my ratios to see if they're similar. So I'm going 6 to 7.5, 8 to 10, and 10 to 12.5. So all of those have to be the same number in order for them to be similar triangles. So 6 over 7.5, 8 over 10, and 10 over 12.5. So see how we get 0.8 every time, or 4/5? That's our scale factor. So that's what we're going to type in here. Oh, from the first triangle to the second triangle. So I have to flip it. Remember, the second triangle would be my new, the first triangle would be my old, and I went the other way. I put this on top. But all I would do would flip all of those, and it's the reciprocal. So make sure you're looking at the right order when you're doing this. So 8, 12.5, and then it's 5/4 because I'm going to this triangle as my new one.